Okay, in this practice, I'll show you how to build a box with parameters from sliders. That means we can control the cube with slider, control the size and the rotation. So let's begin. First of all, I want to set an origin point in the scene, and then we will need three number slider as the size input, and line them, and then we need three number slider as rotation input. Of course, we need operator to convert degree to radians. So also three copy of degree to radians. And now we can begin to create our box. There are actually several ways we can use to create a box, like a center box here, which is I think the most easy way for us for our practice here. And let's have a look at it first. So the first data we need is the base location, which would be the origin point here, and the size is defined by three sliders. And then we can have a full control of the box by parameters from slider. This actually achieve our goal. But in order to practice more about different kind of batteries, I will delete this center box and use a rectangle and a height box instead. First, we use this two input value to generate a rectangle, which we will use rectangle, and this would be x and this would be y, and we also need a plane here. And you can see here we can actually use a point as our plane. It's exactly the same as using XY plane battery to create a plane. I can show you. So even the name of port is plane, it has some default settings which makes it possible to recognize and accept other type of data like the point here. So sometimes you just have to try whether this work. If the point don't work, okay, we can define a plan before we construct a rectangle. And the principle also work for other batteries. You have to use them to find out what is possible. And you can see the origin point is now not the center of this rectangle, right? That's a problem because I want to keep the center at the origin point, but actually we can fix it later. And now we can use this slider as height value, and with rectangle and height we can construct our box. We can of course control size with our slider. Now let's fix the center problem. I must say, of course, you can use center box, use rectangle height box. I here is just for practice, and now I will introduce a new battery called volume. What we can do with volume is we can find the center of this box. You can see this is the box we built, and this is the center of the box. The center is calculated by the volume battery. Now we have the center and the origin point. What we want to do is moving our box from center to origin like this, right? And we can use what we can use is battery called move, and the geometry input would be our box. And for the motion, we need to define a vector first. So the start point of the vector would be the center, and point B would be our origin point, which is here. And now we have a vector. We cannot see it, but we can check it with panel. And here we can see our vector. So now we can use this vector to drive the movement, set it as input, and now you can see the box has been moved from its center to origin. And this is how the workflow of grasshopper work, how to generate and change model with parameters. You define points, generate vectors to guide the movement, and at last change your model. And next we are going to rotate our box. And first, we already have our rotation input, and let's get a rotation battery here. And we need 3 copies of them. So the rotation input should go into angle. The box will rotate around its XYZ axis, so we need 3 input of rotation. And if you don't know, the default settings of rotate is around Z axis. It means if we rotate our box here, by default it will rotate around Z axis of the base, which is in this direction. And we can choose the center. In this way, the first rotation is set. And now we have a problem that if we connect the geometry to the next rotation, we actually not rotate around its XY axis as we want. We are still rotating the box around its Z axis. So now we have to change the box rotate and set the rotation axis to be X and the Y axis. This XY axis is actually not the universal XY axis, but the local XY axis of the box itself. And to define the local XY axis, we need another battery called plane destruction. And plane destruction can extract the XYZ axis. So first we use our geometry here to generate its local XY axis like this. And we put the result into rotate axis. And let's see what happened. Now you can see the box is rotating around its own axis. Also, we can try to rotate around y-axis. Yeah, exactly around the y-axis. I can also tell you something about preview settings. And that's by default setting. I think this button is closed. This is for showing only the selected objects. So if it's activated, only select geometry will be displayed. And if we turn it off, everything will show up. We can also use mid-click to hide unnecessary data and select multiple objects to show it in this mode. But it's just, I prefer to use this preview selected object mode. So these are the whole process. We use point and slider input to generate a rectangle, and we use rectangle and height to generate a box. And we find the center of the box and use this center to generate a vector, which later used to move the geometry to origin point. And then we set the first rotation, and we use the new box to generate local x and y axis, which are used in further rotation. And at last we got our cube, which we can control its size and rotation, or by these sliders. And of course, we can publish our sliders to remote panel, remote control panel. And now we can control it in Rhino. So that's all for the practice, and in our next part, we are going to build our character model.